Hi, everybody. I hope that you guys are all doing well. I wanted to send a video and just kind of keep it short here on the second half of the notes that we started last week on right triangle trig. Last week, we kind of did a little bit of a review on sine, cosine, and tangent. And then we were introduced to these three sort of new trig functions that were basically the reciprocals of sine, cosine, and tangent, and those are called cosecant, secant, and cotangent. Uh, it'll be really important for these problems that you make sure that your calculator is in degree mode. And one of the things that we talked about last week was really using sine, cosine, and tangent to find missing sides and missing angles in right triangles. And we're still going to be doing that here today, but the difference is going to be, these are going to be word problems now, okay? So what you're going to see in a lot of these problems is you're going to see the phrase angle of elevation or angle of depression. And irregardless of which of those two phrases you see, uh, those are both always referring to the angle that is at the bottom of the triangle. Okay, that's typically what you're going to see in all of these pictures here. So let me just give you an example here. You can see here on the left, there's a person that's taking a picture of a bird in a tree, and right here in the bottom right corner, we have labeled that's the angle of elevation. Okay, so if you can just try to remember, angles of elevation, angles of depression are always at the bottom of the triangle. That will help get it in the right place. If you look at this picture over here on the right side, you can see there's an airplane here, and the airplane is flying, so it's parallel to the ground. And you'll notice, though, in this picture, it looks like they have the angle of depression labeled, but it feels like that angle is sort of on the outside of the triangle. Now, when you would have taken geometry last year, you would have learned that when you have two parallel lines, and then you have a line slicing through those two parallel lines, we call that line a transversal. And what happens when you have a transversal going through two parallel lines, it creates all these different angles. One type of angle is what we call alternate interior angles. Okay, so these two angles right here, the one labeled angle of depression and this one right here, are considered alternate interior angles. They're on alternate sides of the transversal, and they're on the interior of the two parallel lines. And so what we know about alternate interior angles is they are equal to each other. And so technically, even though it feels like in the picture that angle of depression is on the outside of the triangle here, technically that angle is also the same angle that we have down here. And you'll notice what's important about this is that whether we're talking about an angle of depression or an angle of elevation, you're going to see that they're both typically at the very bottom of the triangle in your picture. Okay, so just to kind of speed things along here, I'm going to skip this first example. If any of you want to try it, the official answer is 36.27 feet. It's not difficult, there's just a lot of information in it, and I'm going to move down to the example number 2 to start with, because most of your examples are not going to have a picture provided for you already, and what you're basically going to need to do is draw a right triangle, label the given information, and then you're going to use either sine, cosine, or tangent to find either a missing side or a missing angle. So, for example, here this is talking about the hill of a roller coaster, and it says it has an angle of descent or an angle of depression that is 60 degrees. Okay, so let me just draw a picture here of our roller coaster here. Okay, and so basically what we're looking at is you're going up the coaster here. This is the hill that is going up. It says the angle of depression is 60 degrees. And so we know we always want to place those angles of elevation or angles of depression right at the bottom of the triangle. And then it mentions there's this vertical drop that's 195 feet. So once you're here at the top of the coaster, it drops down vertically 195 feet. So I'm going to label that side 195 feet. Okay. The question is we want to estimate what the length of the hill is. And so what we're after is really that side of the triangle right there, okay? So we just need to think through, okay, which trig function is going to be the most appropriate for this? Our options are sine, cosine, or tangent. We are not using the three reciprocal trig functions, cosecant, secant, or cotangent, because those buttons do not exist on the calculator. So if we look at this 60-degree angle here, we can see the 195 is clearly the opposite side to 60. And then the side we're trying to find, which I'm going to label that x, that would be the hypotenuse. Okay, so we want to pick a trig function that's going to incorporate the opposite with the hypotenuse, and that option would definitely need to be sine. So we're going to set the problem up sine of 60 degrees would equal, and then the opposite side, that's 195 feet, over the hypotenuse, that's x. Okay. Once we have that set up, we could simply cross multiply, and we're just going to solve this for x. Now, you would want to make sure that your calculator is definitely in degree mode, not radian mode. If you type that into the calculator, it's very important that you guys are showing this step so I can see the step right here, so I can see what it is you are typing into your calculator to get the answer that you are arriving at. We would label this feet, and the actual answer here is that the hill is roughly 225.17 feet there. Okay, all right, so let's try another one here. Let's take a look at this example. This example is talking about a ramp. It's unloading a moving truck. Okay, so pardon the horrible artwork here. Here's my moving truck. We've got a ramp, okay, which is kind of in the form of a right triangle. They're going to back right up here, up against it, so they can roll some things down off the bed of the truck. Okay, so there's our right triangle. It says here angle of elevation is 32 degrees. Okay, remember where that gets placed. That gets placed in the bottom of the triangle, so that angle in there is 32 degrees. It says if the top of the ramp is 4 feet above the ground, so right up here would be the very top of the ramp. If it's 4 feet above the ground, that's not talking about the hypotenuse. That's directly down from the ground. That would be that leg right there, 4 feet. Okay. The question is estimate the length of the ramp. So what we're really trying to find is actually this hypotenuse right there. And I'm going to go ahead and label that hypotenuse as x. And so once again, we're tasked with just trying to figure out which would be the best trig function to use that's going to incorporate the 4-foot side and side x. Okay, and if we're using this 32-degree angle here, we can see the 4-foot side would be the opposite. The hypotenuse would be the x, and so for this one, we would want to use sine as well. Okay, so we're going to set this up. Sine of 32 degrees would equal opposite, which is 4, over hypotenuse, which is x. Okay, again, we're going to cross multiply. Okay, I'm going to divide by sine of 32, and we type that into the calculator, and we get an answer of 7.55 feet. Oh, you know what? I forgot to mention this. On the previous problem, and I don't know if any of you were thinking this, but on this roller coaster problem, this was actually a special right triangle. You know, we talked about the 30, 60, 90, and 45, 45, 90 triangles. This problem could have been solved without using sine, okay? I don't really have this picture drawn accurately at all, because we discussed that the short leg is always supposed to be opposite the 30-degree angle, and so this is not drawn to scale at all. But the short leg would have been this horizontal leg. The 195 would have been the long leg. Another way of doing this problem is to go backwards from the long leg to the short leg, which means you'd have to divide by the square root of 3. Okay, so this right here is the short leg. And then to get the hypotenuse, you multiply the short leg times 2. And if you type that into the calculator, you would get the exact same answer here as we got when we did just using sine. Okay, there's just a different way of doing that problem. Okay, so let's take a look at one other one here. And then we'll look at one where we're finding an angle. Okay, so this problem here is talking about a house. Okay, and leaning up against the house here, we have a 14-foot ladder. So we're going to let that green little piece there represent the 14-foot ladder, okay? And I'm going to label that, we know that ladder is 14 feet there. Okay, it's placed against the house, and here's our phrasing, and the angle of elevation is 72 degrees. Remember where that goes. That always goes in the bottom of our triangle. So I'm going to label this angle right in here 72 degrees. Now let's look at what the question's asking. The question wants to know how high above the ground is the very top of the ladder. Well, we've got the ladder leaning right here. Right here is the top of the ladder. So the question is, how high is that top of the ladder from the ground? I'm going to label that side X. That's what we're looking for. Okay, so once again, we go back, we think SOHCAHTOA. We got to pick which trig function is going to actually incorporate side X with side 14 as it relates to this 72-degree angle. It looks like, gee, all these problems seem like they're sine problems, but they're really not all always going to be sine problems. This would be sine of 72. And we would set that equal to opposite, which is x, over hypotenuse, which is 14. Okay. Again, with the cross multiplying, and then we would type this into the calculator, and we would roughly get that that ladder is reaching up at the house about 13.31 feet. Okay. Okay, so this last problem is a problem where we're actually asked to find an angle. Okay, so this is talking about an airplane, a biplane. Okay, so oh, this is going to be so bad. I'm so sorry here. Okay, here is this airplane that's flying horizontally down here to the ground, so it's flying parallel to the ground. Okay, when it says it's 2,000 feet, that means if it were to drop straight down out of the sky, okay, the altitude of that plane is 2,000 feet. So we want to label that 2,000 feet. Okay, when it says it's 50,000 feet from the runway, and here's the key phrase here, as measured along the ground. So let's say right here's where the runway starts. Measured along the ground here, this is the 50,000 feet. Okay, the question is, what is the angle of depression that the biplane should make in order to have a smooth landing? So it's going to tilt the nose of the plane down so that it can make it right here to the runway on time. Remember, that angle of depression is technically out here on the outside the triangle, but we know because of alternate interior angles, angle of depression is actually also going to land right in there at the bottom of the triangle. Okay, so we need to pick a trig function that's going to incorporate the 2,000 with the 50,000. Okay, so now if I'm using theta right down here in the bottom right corner, it looks like the 2,000 is the opposite, but the 50,000 is the adjacent. So for this one, we would want to use tangent. So I'm going to set up tangent. I don't know the angle, so I'm going to make that theta. I'm going to put opposite, which is 2,000, over adjacent, that's 50,000. And remember, last week we said now the way to solve for an angle is you have to take the inverse trig function to break that trig function off of the theta, and then you have to do that same thing to this side. So what you would type into your calculator would be inverse tangent, that's, you have to put the second key there, 2,000 divided by 50,000. That would give you roughly 2.29 degrees. If you rounded it to the nearest tenth, it would be 2.3 degrees. And obviously my picture's not drawn to scale, but on these airplane problems, you definitely expect that, this angle in here should be a really small angle, because if you've ever flown in a plane, when it tilts the nose of the plane down, it's at a very, very gradual angle. Okay, I'm hoping that this will be good enough information here for you guys to go ahead and try the homework. The homework is not this entire worksheet, but it's only to do, I think it's problems 1 through 6, and then maybe 13 through 21 odd. This is going to be posted on Google Classroom, and it's got which problems you need to work on there. So hope you guys are all doing well, and we will talk to you soon.